Hello guys and welcome to the GCE panel online. I'm Dr. Mais, your host, and in this lesson we are looking at Introduction to Vectors. I implore your indulgence to subscribe to this channel and to watch this video to the end. This video is both for mathematics and further mathematics advanced level. Welcome, stay tuned, and don't forget to like, share our videos, and join our online preparatory classes. So we begin by looking at an introduction to vectors. A three-dimensional space is defined by three perpendicular axes that intersect at the point O, which is the origin. Let us picture the corner of a room. Looking at the corner of a room, we will have the OX, the OY, and the OZ axis respectively as is being displayed on the figure below. So we have the OX, the OY, and the OZ axis, where O is the origin. Each vector in space is defined with components that are parallel to each of these axes. For example, vector A in space, where A is an element of the set of space, that is R to the power 3, it shall be of the form A equals xi plus yj plus zk. That is a space vector. Space vector means three components. If we're talking of a vector on a plane, we will normally talk about two components, maybe just the I and j components, or the j and k components, or the I and k components. So that would be a two-dimensional vector. But for a vector in space, we have the I, the j, and the k components. So another notation for a vector in space can be written like this, with these brackets, x, y, z, as you can see. And in column form as well, it can be written as this in column matrix form. So a vector can equally be written in column matrix form. So each of these three notations can be used to describe a vector. Right, so the three-dimensional space is bounded by the planes xy, yz, and xz. Those are the planes that we have. Let's take some examples. State whether or not the following are a line, a plane, or a space, and state the axis or the plane. So if it is a line, give the name of the line. If it's on a plane, state the plane. And if it's in space, then that will just be enough to say it's in space. So the first one, we have minus 5i. Minus 5i. So this is just the I component. So this on a line, right? So normally this should be a line, and this should be the x-axis. X-axis, or this just you have just an I component. For B, we have the j and the k component. So this vector should lie on the yz plane. And for C, we have all three components. So this one should be in space. For D, please speak with me as you watch the video. We have just the I and the k components. So what plane will this be found? Because there are two components. We are going to have the x z plane, xz plane. And for the last one, of course, you know the plane, right? Of course, everybody knows that is the xy plane. All right, so you can visit us at www.gcepanel.com, or you still click gcemathpanel.blogspot.com. We will still meet us. So but just type on www.gcepanel.com, www.gcepanel.com. Yeah, that's our new address. All right, let's continue with our class. Now we look at the components of a vector. No, I'm going slowly because students have complained that sometimes you go so fast. So we now look at the components of a vector. So we are following this outline that you can see at the left of the screen. So for the components of a vector, so given the vector, A with components A1I plus A2J plus A3K. The vector below has components given by A1, A2, and A3. So these are the components of this vector. The components of a vector answers the question, how many I, how many J, how many K? Those are the components. So how many I? A1. How many J? A2. How many K? A3. So which are the I, the J, and the K components respectively? So that's just all of the components of a vector. We can now look at the direction ratio of a vector. So for the vector above, the direction ratio is given by A1s to A2s to A3. So we just take the components and put it in ratio form, and that gives us the direction ratio of a vector. So the components, we use commas. The direction ratio, we use columns. Direction ratio, we use columns. So you can visit us equally at www.gcepanel.com, not GCE Math Panel, or you take gcemathpanel.blogspot.com. The magnitude or the modulus of a vector. The magnitude or the modulus of a vector. So how do we get the magnitude or the modulus of a vector? Well, the modulus or the magnitude of a vector is the line segments that represents that vector, the length of the line segments that represents that vector. For example, if you have this vector with components A1, A2, and A3, then the modulus or magnitude, which is denoted by the absolute of that vector, absolute value of that vector, is given by the modulus of magnitude of A is equal to this root of the sum of squares of the components. That is the square root of the sum of what? Sum of squares of its components. So for any vector, its modulus or magnitude is given by the root of the sum of squares of its components. And note that the modulus or magnitude is always positive because length is positive, scalar. Now let's look at the unit vector of a given vector. Let's call it A. We want to look for the unit vector of the vector A. And normally unit vectors are always denoted with caps. As you can see here is a cap like this. And most of the time when we write I components, can you see I is the unit vector, J is a unit vector, K is a unit vector. Now, how do we find a unit vector in the direction of a given vector? To find a unit vector in the direction of a given vector, we are going to proceed as follows. We proceed as follows. So a unit vector is one whose magnitude, first of all, is unitary. So given the vector A, the unit vector in its direction is denoted and given by a unit vector is equal to a vector divided by its magnitude or modulus. So that's going to be given by A over mark A. A over mark A will give us a unit vector in the direction of A. Most of the times they'll ask us to look for a unit vector in the given direction of a vector, and we have to do that by looking for A divided by mark A. We're going to take some examples at the end. Now, the direction of a vector. The direction of a vector depends on whether it is on a plane or in space. So we are going to look at the first case, the direction of a vector on the XY plane. This was what you already know from Form 4 and Form 5 work. So it's the same principle. So a vector on a plane, that is r squared means plane, r cubed means space. So if you have the vector A equals A1 plus A1I plus A2J, then its direction is the angle it makes with the positive x-axis or any other line that is parallel to this positive x-axis. So the angle of a vector is the The direction of the vector is the angle it makes to the positive x-axis or any other line parallel to this axis. So from here, if you call that angle theta, then our theta will be equal to tan inverse of the j component on the I component. That's going to be theta is equal to the arctan j component over the I component. That's good. So for the second case, where we have a vector in space, that is in R cube, then we have the vector A, the components A1I plus A2J plus A3K. Then the position vector OP of a point P makes an angle alpha, beta, and gamma with the positive X, Y, and Z axis respectively. So unlike a plane, in space, the vector OP makes three angles. It makes an angle with the positive OX, an angle with the positive OY, an angle with the positive OZ axis respectively. So from here, we are going to talk about cos alpha. For alpha, we are going to use the first axis, that's the OX axis. That will be cos alpha will be equal to A1 over Mach A. Cos beta, the angle that it makes the OY, will be A2 over Mach A. And cos gamma will be the angle it makes with the OZ, which is A3 over Mach A. Now, there is something very, very important about all of these three angles which we are looking at here. These ratios, that is cos alpha, cos beta, and cos gamma. Note that when we are talking about an angle on a plane, we are talking about arctan. We are using the tangent, arctan. However, in space, we talk about cos alpha, the angle it makes the positive x-axis, cos beta, the angle it makes with the positive y-axis, and cos gamma, the angle it makes with the positive z-axis. And these are the angles that any vector OP will make. Now, these ratios will give us what we call the direction cosines. I'll discuss this shortly. So these quantities, cos alpha, cos beta, and cos gamma, are called the direction cosines. Direction cosines are different from direction ratios. Direction ratio is just a ratio of the components, while direction cosines is almost the same like that ratio, but each of those components is now divided by the modulus of the vectors. You can see here. This is the I, A1 over the modulus, A2 over the modulus, A3 over the modulus. So this gives us, if we letter these angles L, M, and N respectively, then we'll see that cos squared alpha plus cos squared beta plus cos squared gamma should be equal to 1. So well, let's look at this. So if cos alpha to be equal to L, cos beta equals M, and cos gamma equals N, then for the direction ratios, this property holds. Cos squared alpha plus cos squared beta plus cos squared gamma is equal to 1, or L squared plus M squared plus N squared is equal to 1, which therefore means that if you know one of the angles, let me say you know two of them, then you can look for the third. For example, if you know L and M, you can look for N. N, where N will be the angle it makes the positive Z axis. Okay, now let's move on. So let's take the first example. Now you are given the following vectors: A equals 2I plus 3J minus 4K, B equals I minus 4K, and C equals 2I minus 2J plus K. Now, so we should find the modulus of A, B, and C. Sub 2, state the component of C. Sub 3, the direction ratio of A. Sub 4, the unit vector in the direction of C. And sub 5, the direction cosine of A. So now we are going to touch all of those things we have just looked at in this particular example. So solution. So the first one, to find the modulus of each of them, this is going to give us for the first one, that's going to be the square root of the sum of the components. So we are going to have 2 squared plus 3 squared plus minus 4 squared. And the square root of that will give us root 29. We do the same for B, we will have root 17. And for C, Root 3. You have to show you're working, but this is something you already know how to do it. And you know, this on our screen does not have enough space, so we just have to take it like this. Now, sub 2 to state the components of C. What are the components of C? The components of C are the coefficients of I, J, and K respectively, right? So we have 2, -2, and 1. Of course, we have, so for C, C1 is equal to 2, C2 is equal to -2, and C3 is equal to 1. Then for sub 3, the direction ratio of A. The direction ratio is a ratio now of the components. So for A, we are going to have 2 to 3 to -4, right? Yeah, the ratio of its components, 2 to 3 to -4. Then for sub 4, the unit vector in the direction of C, we know that the unit vector of a given vector is given by the vector over its modulus. So that just give us C over mark C. Okay. So, however, this C here is not this cap, it's a straight line. Please take notes. This C here is a straight line. So this will give us 2. Normally, we already know that for C, the absolute value or the modulus is 3. So we just have 2 over 3 minus 2 over 3, 1 over 3. All right, because absolute value of C here is 3. So we just replace it here. That's why we have this one like this. Now to find the direction cosine of A, we already have the modulus of A to be 29, root 29, right? So the direction cosines for the OX, we have cos alpha to be equal to A1 over the modulus of A, and that will be equal to 2 over root 29. Cos beta will be equal to A2 over mark A, which is equal to 3 over root 29. And cos gamma will be equal to A3 over mark A, which is equal to -4 on root 29. So you can see that the example is pretty simple, right? So another thing they can do is that they can give you a vector and they say you find a vector that is parallel to this given vector and has modulus of that. We are going to see that in the next example. So here we have if R is equal to 4i plus 3k, find a vector with magnitude 2 in the direction of R. Find a vector with magnitude 2 in the direction of R. So here we're going to say let the required vector be A. Now we know that A over mark A should be equal to R over mark R. This is the idea you are going to use. Note that this R here is a vector, okay? Though it's not on the line, but it's bold. So this is the idea you're going to use to look for a vector of magnitude 2 in the direction of R. So A over its magnitude should be equal to R over its magnitude for all vectors. So this will imply this our vector A will be equal to R over mark R times mark A. And this will be equal to 2 over, that's because our mark A is equal to 2, right? All right, let me see. So this is going to give us our mark A is equal to 2. Okay, thank you. Why our mark R is equal to 5? That's 4 squared plus 3 squared, the square root of that. But show you're working, don't forget that. So this can be written as 2 over 5, where 2 is the magnitude of the A, the vector A, and 5 the magnitude of R into the vector R itself. So this is a vector of magnitude 2 in the direction of A. Guys, please, if you watch this video, don't forget to subscribe to this channel and to share our videos on YouTube. We implore your indulgence that we can reach as many more students as possible through you. And don't forget to leave your likes and your comments. If there are some topics you'd like us to do, why not leave your comments and join us equally for online revision classes by just visiting www.gcepanel.com, where you are going to have more of our videos, www.gcepanel.com. Or you can go to our normal other site, gcemathpanel.blogspot.com, and you'll still bring you to the same page. So for more, please visit www.gcemathpanel.blogspot.com, or you visit www.gcepanel.com. Join us for our live classes for mathematics, additional mathematics, physics, chemistry, and a lot more. We currently have a lot of sample papers and past questions, which you can get them all from this website of www.gcepanel.com. and a lot more. From there, you can get to us directly on message. Thank you so much, and don't forget to subscribe. Bye-bye.